Okay, in the Chapter 5 review, the first question says that the cosine is 7/25 and that the sine is less than 0. So we know that our cosine is positive because it's a positive 7/25. And if the sine is less than 0, then that means that our sine is negative. The cosine is positive and the sine is negative in quadrant 3. This will allow us to find the sines of the remaining trig functions. The sine is negative in quadrant 3. The tangent is also, this is quadrant 4. Sorry, cosine is positive and sine is negative in quadrant 4. The tangent would be negative, the cosecant would be negative, the secant is positive, and our cotangent is negative. We can only use identities, no triangles, to find the remaining 5 trig functions. Well, no work is necessary to find the secant because all we have to do is take the reciprocal. Now, one of the easiest identities, or the one that everybody seems to remember or use first, would be that the cosine squared plus the sine squared equals 1. We have the cosine, so we fill in 7/25. We square it, and we get 49 over 625. We subtract 49 over 625 from both sides. Then we take the square root. Now we're taking the square root of a variable. So it would technically be plus or minus. But we know that we are in quadrant 4, therefore the sign is negative. So we get that the sine of x is negative 24 over 25. Take the reciprocal, and we get 25 over 24. Now to find our tangent, we could take the sine of x over the cosine of x using our quotient identity. The 25's cancel and we're left with a negative 24 over 7. We take the reciprocal. For our cotangent, we get negative 7 over 24. 2 through 4 says to rewrite the following expressions in terms of sine and cosine. Simplify your answers. Do not leave a quotient in your final answer. Okay, so I'm going to change the tangent to the sine over the cosine. I'm going to change my secant into 1 over the cosine and my cosecant into 1 over the sine. I can multiply these two and we end up with the cosine of x times the sine of x in the denominator. Well, now to subtract these, I can find the common denominator. And we can multiply the first fraction by the sine of x over the sine of x. So now we get the sine squared of x over the cosine of x times the sine of x, minus 1 over the cosine of x times the sine of x. What you might recognize here is that the sine squared and 1 appear together. We know that the sine squared plus the cosine squared equals 1. But we have a positive sign and a negative one. So we can divide everything in our identity by negative 1. These two are the same. We can reverse the order. Negative cosine squared of x equals the sine squared of x minus 1. So now I know my numerator is equivalent to a negative cosine squared. And then we have over the cosine times the sine. Now all of this is multiplication in our denominator, which allows us to cancel. Then we're left with in our numerator a negative cosine of x, and in our denominator a negative sine of x. The cosine over the sine we know is our cotangent. So we end up with a negative cotangent of x. In number 3, it does say to convert things into sine and cosine, but you don't necessarily have to do that immediately first. You can, but what I see here is a 1 and a trig function squared. We have a Pythagorean identity that 1 plus the cotangent squared is equivalent to the cosecant squared. So I'm actually going to do that first. Now I'm going to convert things into terms of sine and cosine. From here, my sine squares cancel. We're left with 1 over the cosine squared. And 1 over the cosine squared is the secant squared. Okay, the last one. Converting to sine and cosine. There are other identities that we can use. I'm just going to convert to sine and cosine right away, which then the next step, the only thing that we could possibly do is find a common denominator. So we have to multiply the first fraction by the cosine squared over the cosine squared. We have to multiply 1 over the cosine squared times the sine squared over the sine squared. So we end up with a cosine squared over cosine squared times sine squared plus the sine squared over the cosine squared times the sine squared. Okay, now, when we look at our numerator and we add them, we have a cosine squared plus a sine squared. This cannot cancel with anything in our denominator because our numerator has addition. So we can't cancel out the squares or anything like that. We can only do that if it was all multiplication in our numerator. But we know that the cosine squared plus the sine squared is a Pythagorean identity. It equals 1. So at this point I don't have an identity in the denominator, but it does tell us in our directions that we can't leave anything in quotient form. Therefore, I can move my cosine squared into the numerator, converting it to secant, and I could move my sine squared to the numerator by converting it to its reciprocal, the cosecant. So we end up with the secant squared of theta times the cosecant squared of theta, or maybe based on how you wrote out your denominator, maybe you had sine squared times cosine squared. Your final answer might appear the cosecant squared times the secant squared.